Hello everyone, this is the January 22nd Regents from 2020, the Algebra I Regents in New York. We are going to get right to it. We're going to just go over all the little tricks that you need to use your calculator. So this is going to be a beneficial video for everyone. All right, if f of x equals, this is number 1, 2 times 3 of x plus 1, what is the value of f sub 2? All right, so we're going to have to substitute anything that is inside. This is what they really want you to do here. Anything that is inside this parenthesis, that's it. I want you to think of that as the input. All right, so really what you have to do, and what they want you to do, is to substitute the 2 in everywhere you see the x. And just like that. All right, this is a pretty easy one, but I'm just going to say, all right, if you want to use your calculator for this, you just go to y1 and you put in 2 times 3 to the x power plus 1. Once you have that in, it's going to give you every per second function table, and it's going to give you every input, not just the input that you're looking for. The input that they're looking for is 2. So we're going to go down to 2, and 2 is right here. So 2, 19, and that is your answer. All right, for number 2, high school sponsored badminton tournament. Sponsored a badminton tournament. After each round, 1/2 of the players were eliminated. That is a very important part right there. 1/2 of the players were eliminated. We are talking decay at this point. So 64 players were at the start of the tournament, and which equation models the number of players left after 3 rounds? Anytime that you have a decay, it is 1 minus whatever percent that they're decreasing by. So everything with plus, this is not a decay. That's not a decay. This is not a decay. So if you were increasing the amount of players, then you would pick plus. If you're eliminating, that is called a decay, and the decay is 1 minus. So we're going to talk about this 1 minus 0.5 and then 1 minus 0.3, just focused on what's happening inside the parentheses. So it says that 1/2 of the players were eliminated. That means 50% of the players were eliminated. If 50% of the players were eliminated, you're going to change that to a decimal. It is 1 minus 0.5. And then because it's they want to know how many players were left after 3 rounds, it is a 3 right here. After 3 rounds, 1 is your answer. For number 3, they're just asking you which number is not in the solution set. So what I'm going to do is I'm just going to rewrite this inequality, and I'm going to subtract 2 on both sides. 7x is greater than or equal to 56. You divide by 7. And you get x is greater than or equal to 8. So you would say, okay, wait, 12 is greater than or equal to 8. 10 is greater than or equal to 8. 8 is greater than or equal to 8. They're looking for which number is not in the solution set. So the solution set is all numbers greater than or equal to 8. The only number that is not in the solution set is 6. Just be careful with that one. That's a tricky one. All right. Which table could represent a function? Just remember, a function is that every x value has its own y value. And I want you to know the f of x, the g of x, the h of x, the k of x, that is your y. All right. That's your output. The x is always the input. So every x must have its own y. So what you do is you kind of focus in on the x on the x values. If it repeats, just check the y that it's going to a different y. Every x must have its own y. So that means if the x repeats right here and right here, 2 is already attached to the output of 2. This 2, this input, is attached to the output of 6. This is not a function. So we're going to look at 1, 2, 3, 4. Every x is different. So that means every x has its own y. That is the function. I just want to go over 3. 2 is repeating, and it's going to 2 different y's. That is not allowed. And then 3 is repeating, and it's going to 2 different y's. That is not allowed. That is not a function. 2 is a function. So number 5, which value of x makes this true? This mess right here. So all I'm going to do is actually substitute here. I am not going to try to solve it, right? I'm going to put into my calculator alpha x. Alpha x is how you get to the quick fraction, inputting a fraction. So that right there is set up. So it's x minus 3. So I'm going to put, instead of x, I'm going to try 8. So 8 minus 3, I'm substituting my 8 in for x, and that's over 4. And I'm going to add the 2/3, so plus, and then alpha x again for another fraction, setting up that fraction 2/3, and now I'm going to press enter. And it's 23 over 12. I'm supposed to have 17 over 12, so I know that 1 is not my answer. 8 is not my answer. All right, so now I am going to do the same thing. I'm going to try 6 this time. So 6 minus 3 on the top is the numerator, and the denominator is 4. I'm substituting the 6 in for x. That is plus. We're going to add that to 2 over 3. And we're going to press enter. 17 over 12. 2 is my answer. And that's how you do that. You just use your calculator, substitute whatever number that you choose first into this x. 6 is the only one that works. It equals 17 over 12. So 6 is the one that's true. Number 6, which expression is equivalent to 18x squared minus 50? By the way, you could take this and put it directly into y1 and then try number 1 and number 2 and number 3 and number 4. The graphs match, that's your answer. If the graphs don't match, that's not your answer. All right, but let's go ahead and do this by hand right now. You have 18x squared minus 50. So just remember, we're talking about setting up 2 parentheses, and we really want to look at 18 and 50. We're looking for GCF, which is the greatest common factor. So you're saying, okay, what number, what's the greatest number that goes into both of those? And we're saying, okay, I'm starting at 18. 18 doesn't go into 50. 9 doesn't go, 9 goes into 18, but 9 doesn't go into. So now we're going down, and then we're saying, okay, 2. 2 goes into both. All right, so 2 times what equals, we're going to pull that 2 out. They don't have an x. 2 times what equals 18x squared. 2 times 9 equals 18. Don't forget the x squared. So now if you do distributive property, 2 times 9x squared equals 18x squared. 2 times what equals negative 50. 2 times negative 25. Now you're looking, okay, now I pulled out the 2 as a greatest common factor, and now inside the parentheses, I noticed like it's like a difference of squares. And when we're talking about a difference of squares, we're talking about perfect squares. All right, 9 is a perfect square, 25 is a perfect square. So we're going to just go ahead and we're going to set up two sets of binomials, just like this. And we're going to ask ourselves, what times what equals 9? It's the same number, 3x times 3x equals 9x squared. And then we're going to ask ourselves, what times what equals 25? It's a perfect square. So 5 times negative 5. And that is it. We could tell right now that 3 is your answer. Just remember, there's a couple of ways that you could do this. You see this right here? This means 3x plus 5 times 3x plus 5. So 5 times 5 cannot equal a negative. And this negative 5 times negative 5 cannot equal a negative either. You could cross those out. Negative 5 times positive 5 equals negative 50. Negative 25 times positive 25 does not equal negative 50. So 3 is the only possible answer. And then also, I'm going to put that into the calculator, and I'm going to show you how to do it in the calculator if you don't want to do it by hand. So I put them into the calculator, and I'm just going to show you this because you really don't have to do any work for this. So we're talking about this graph right here. There's the first parabola, and you see the second parabola is in red. And it's the same coordinates. So that's the one that works. That is the only one that works. And that is your answer. All right, the functions x squared minus 6x plus 9 and g of x, f of x plus k are graphed below. Which value of k would result in the graph of g of x? So we're going to just kind of focus in on this right here. So the f of x graph is right here. All right, and actually crosses at 9. So we're talking about that graph right here. And then they want to know, all right, what happened to the g of x graph to move it down 2? So what you really have to do here, if you don't know what will move it down, translate it down to, you really have to use your calculator. And when you set up this up into the calculator, it's this, which is x squared minus 6x plus 9. And then you could basically put in, substitute in whatever k value from the choices. So which one would move it down to? All right, I'm thinking this one, move it down to. So outside of parentheses, it isn't, inside parentheses. Moving it up 2 would be plus 2. Moving it down 3 would be down 3. This moves down 2. So 4 is your answer. But I'm going to come back and we're going to put these into the calculator as y1 and then y2. And then I'll show you exactly what happens. So now I have both of my parabolas in the calculator. I have the first one that they gave me, and then I have a minus 2 because I wanted to kind of just like take this minus 2 and substitute it in for the k. So that would be minus 2, and that's where I'm getting that from. I could try all these others. It won't translate it down 2 units. So I'm going to just go ahead and press graph and show you that that parabola is down, that red parabola, translated down 2 units, and that's how I got my answer. All right, so I can't stand these questions, but, they're here and they seem to love them that they ask. But if they're asking, the shaded boxes in the figure represent a square, and it says how many, if this pattern continues, how many shaded blocks will be in figure 35. Okay, so I'm gonna count the shaded boxes. This is 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're starting with 12, and then this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16. And then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm looking at the difference here. the common difference, and it is a +4. All right, and then also it's a +4 here as well. So obviously figure 4 will be 24, figure 5 will be 28, and then so on and so forth. I don't want to count all the way up to 35. So what I'm going to try to do is put a y equals mx plus b together. Since my first value, the initial value is 12, I'm going to put that y equals, and I'm going to put a 12. Because I know that the initial value is 12, and I know that it's increasing for every figure. But the problem is that with the initial value, it's usually that it's the y-intercept. And the x is usually 0 when the initial value, when the y-intercept is the y-intercept, the x is 0. So I'm going to put a 0 in. And this is figure 1. Right? So for the 0, that represents y equals 12, and that works out. Then I'm going to try it for the figure 2. So for figure 2, I'm putting in 1. And that is y equals 16. And that seems to work out. So every time I want figure 2, I have to put figure 1. Figure 3, I have to put 2 in as the x. Figure 4, I have to put 3 in as the x. So if I wanted to go to figure 35, I would have to substitute 34 in. So it's 4 times 34 plus 12. And so that'll give me the exact amount of shaded boxes in figure 34. So it's 4 in figure 35. 4 times 34 plus 12, and that is 148 shaded boxes, and that is 2. For number 9, the zeros of the function. Remember, the zeros are, we're talking about the x-intercept, where that parabola crosses the x-intercept. So there's really only one way to do this. Grab your calculator. You're going to put x to the third minus, you're going to clear this out from the last time. You're going to put x to the third minus 9x squared. Let me just make sure. Yeah, it is 9x squared. And we're going to just look at this graph. Okay, so let me just, anytime you want, like mine, I messed with the window a little bit before I started. So anytime that you want the window to be 10 by 10, you want to go to zoom and press 6. So I'm going to get that to 10 by 10. This definitely crosses at 0. So we're going to say that 0 is definitely a part of my answer. 9 only is wrong. 0, 0, and 0. So let me go back to the calculator and see exactly what's going on. It is only crossing, it's crossing here at 0. It goes down, and then it goes up again, right? So this is the number that it crosses at. And you get 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to talk about this right here. See this 9, 0. So it's definitely 9. It's not 3. So we can cross out that, cross out that. This is the answer. Anytime they talk about the zeros, they're talking about the solution, the x-intercept, where it crosses the x-axis. So for number 10, this is a two-way table, and it says in middle school conducted a survey of students to determine if they spent more time playing games or watching videos on their tablets. The results are shown in the table below. Of the students who spent more time, playing games on their tablets. Remember, you always set up a fraction with the part over whole. So it's always part over whole. So that means the bottom number of this fraction, the denominator, has to be the greater number. So of the students who spent more time playing games on their tablets, of all students, 192. Approximately what percent were boys? 138 out of that 192. So obviously grab your calculator. 138 divided by 192. Enter. It is 0.710, 0.71875. And it says approximately what percent. So they want you to round that, 72%. You move the decimal over twice, you get 71.8%, 875%, and you round it to 72. 11. Which best describes the solutions of a two-variable equation? Solution. Think about a two-variable equation, and when you graph a two-variable equation, you're graphing a system, right? Like y equals 2x plus 3, and then y equals 4x minus 10. The ordered pairs of the solution must be where? Are they going to be on the graphed equation? Are they going to be near it? Are they going to be, must have x equals 0 for one coordinate? Are ordered pairs, they have to have y equals 0? No. The ordered pairs must lie on the graphed equation. So when you go just to kind of put a little sketch together, any kind of linear function, just let's say something like that, the solution is always on the graphed equation, not off it, not near it, not, does it definitely have to have x of 0? No. Does it have to have y of 0? Absolutely not. So that's the way to do that. Again, this is the type of question that's asking you to factor. So I'm going to rewrite x squared minus 10x plus 24. If you do not want to do this, you put it directly into your calculator. You put this in as y1. Then you put this in as y2. This number 1. And you see if it is matching. If it matches, that's the answer. If it doesn't, go on to number 2 and match it that way. But we're going to do it by hand. And we're going to ask ourselves, what two numbers multiply to equal 24? So I'm going to put 24 here, and it's a positive 24. 1 times 24, 2 times 12. All right, I'm going to stop because the two numbers that I pick that multiply to 24, they have to add to a negative 10. Can you make a negative 10 out of 2 and 12? That's why I'm stopping. Like, I'm not going to 3 times 8. That doesn't make a 10, right? And then 4 times 6, that makes a 10. So that might be it. But I'm going to stop here. And I'm going to say, okay, it has to be x and x. So is it 2 and 12, though? It has to equal a positive. And this has to add to a negative. So if I put a negative 10, right, to make a negative 10, 12 has to be negative and 2 has to be positive. 2 minus 12 is negative 10. But 2 times negative 12 is not positive 24. So this is out. So this is out also. I can't make a 10. But I can make a 10 out of 4 and 6. And look, see this? This is a positive 24. Positive times a negative can't be the answer. Negative times a positive can't be the answer. It could either be positive, positive, or negative, negative. Just one thing about positive and positive. If it's positive, positive, that means every number here in this trinomial is positive. Every number is not positive. This is a negative 10x. It can't be 6 plus 4. That would be a positive 10. 4 is definitely your answer. Just let me see This right here to be negative 10, both of them have to be negative. And let me just check it out. Negative 6 times negative 4 is a positive 24. Negative 6 plus negative 6, negative 4 plus negative 6 is negative 10. So this is your answer. And again, please put this into Y1. Put this into Y2. The graphs will match. The same graphs. That's your answer. So you don't have to do any of what I did on, as for the work. This is multiple choice. Nobody cares. So for this one, again, grab your calculator. So we are going to grab that calculator and we're going to put that trinomial in the calculator as Y1. We're going to press graph. And there is the parabola. So we're just going to look. The minimum value of g of x is greater than the minimum value of f of x. So just take a look. This is g of x. This is f of x. So this is on your calculator. The minimum value of g of x is here. It's the lowest point. The minimum value is the lowest point of the parabola. 1, 2, 3, 4. So the minimum value. The maximum value of f of x, the maximum value is here. That is 0. So I'm going to put that 0 in. So the minimum value of g of x is greater than the maximum value of f of x. Sorry, the minimum value is negative 4. That is my mistake. Negative 4. Is it greater? No, it's not. Cancels. The f of x and g of x have the same y-intercept. So the y-intercept is pretty easy of g of x. It's right here. It's where it crosses the y. So that's negative 4. So I'm going to put that as negative 4. And then I'm going to look at my y-intercept of the other parabola, and it is negative 4. So that means they're equal. Is it the same? Yes, it is. 2 is your answer. And you could cross the other ones out. Number 14. The equation VT equals 12,000 times 0.75 to the t power represents some value of a motorcycle after t years. Okay, this is your equation. Represents the value of a motorcycle after t years, after it was purchased. Which statement is true? The motorcycle cost $9,000 when purchased. You have to know what this number means. That is the initial value. If that's the initial value, it didn't cost $9,000, it cost $12,000. The motorcycle cost $12,000 when purchased. Yes. 2 is your answer. There's no way. You really have to look at the rest of it. Cost $12,000. It is not decreasing at a rate of 75% a year. Remember, inside those parentheses, that is a decay. It's a decrease, but it's 1 minus 0.25 to get the 0.75. All right, and this is indicating, if they asked you, a 25% decrease in value of that motorcycle every year. All right, but number 2 is the answer, choice 2. All right, solutions. Whoa, I don't know. This looks crazy to me. All right, but there's one thing that you have to do before you use your calculator. We're going to put this directly into the calculator by making it equal to 0. All right, just make sure that you have to remember it's y equals for a reason. So this cancels out and you have x plus 4 squared minus 9 equals 0. Now I'm going to grab my calculator and put x plus 4 in parentheses and I'm just going to make sure that I'm going to get this right. Squared minus 9. Just like this. And then we're going to press graph. We're going to look at that parabola. Wow, it crosses at -1, 1, 2, let's see, 2, 3, 4, 5, 6, 7. -1 and -7. 3 is your answer. You're done. No other way to do it. All right, there is another way to do it, but you shouldn't be doing it that way. You put it into your calculator, read where it crosses the x-axis. They're asking for the zeros. They're asking for the solution. They're asking for the x-intercept. Read it. Look at it. You're good. All right. You can look at the table as well to figure out what's going on, and that's it. All right. Which expression is not equivalent? All right. Not equivalent. So I'm just going to go ahead and do distributive property. Find this very easy. Again, you could put this in y1. You could put this in y2. The graphs won't match up if it's not the answer. All right. So you could use your calculator every single time. I'm going to do this by hand though. X squared times -4x. That is -4x to the third. I have that. So I'm going to keep on going. Then it's plus x squared. I have that. I'm going to keep on going. -2 times -3x is -6x. I have that. I'm going to keep on going. And then I have a plus 8. This is equivalent, so that's out. X squared times -4x squared is -4x to the third. I have that. I'm going to keep on going. Positive times a negative is -x squared. I have positive x squared. This is the one. Done. Right? Just take your time. And again, put it in the calculator if you need to see it. Right? These will match. 1 and this will match. 3 and 1 and this will match. 4 and this will match. These will not match. That's the one that is not equivalent. So there is a way to do it with the calculator. Which situation could be modeled as a linear equation? Just remember, linear has to have the same rate all throughout the line, the whole equation. Right? The value of a car decreases 10% every year. That changes. So if the car is 20,000, then it decreases 10%. That new amount is going to be 10, and then the next year decreases another 10% on the new amount. So that means it's going to change every year. It's not a constant. So that means one is out. The number of fish double every 5 years. That's out. 2 liters of water evaporate from a pool every day. That is constant. That is the one that's linear. Number 18, the range. The range is the y value. I'm going to grab my calculator again. And the one thing that students always ask me is, where do we find absolute value? So we'll go over that right now. You press math and you see this NUM for number. That right there is absolute value. You leave it on 1, you press enter, and it'll bring you back to the y equals. So this is x plus 3. You put that inside the absolute value bars, and then -5. So I'm going to press graph, and I'm going to look at that graph right there, and I'm going to focus on the range. The range is just the y. We're talking about the y, up and down, not left or right. So it starts right here, and I think that is 1, 2, 3, 4, 5. This is -5. It does not go below that, but it does go forever all the way up right there in the y-axis. So the range is -5. This is out. This is out. -5 and infinity. -5 and infinity. These brackets, just remember, the bracket means that it is equal to -5 and not the parenthesis. The parenthesis means that it's not equal to -5. All right, remember, it is equal to -5 because it meets there. Like it hits -5. If you see it, see that right here? -3, -5. It is equal to -5. So you must have this bracket, and every time on the side where there is infinity, there's a parenthesis. All of the time. All right, there's never a bracket. It can't be equal to infinity. All right, so Remember, a bracket means equal to as well. And 1 is your answer there. Number 19. Laboratory technician used this function to model the research. Consider the following expressions. All of these expressions, right? Grab your calculator. That is really just the only way to do this. It's the quickest way. People that don't put this into the calculator will be guessing. Don't be one of those people. So 2x plus 1, exactly what it is, except for, the m being an x. And then I'm just going to go down, and I am going to put that first one into the calculator. So this one right here. So it's 6 times 3 to the 2x power. I'm going to press graph. That looks exactly the same, and I just want to make sure that it is. It looks the same. It is the same. The tables are the same, so 1 must be the answer. One of the answers. So 1 could be a possible answer. 2 only, that's out. 1 has to be part of your answer. That's out. So now we're just going to check 3. All right, because 1 is an answer. So I'm just going to go to 3. There's really no reason to check 2. That's it. That's it. So I'm just going to put that directly in. And I'm going to put 6 times 9 to the m power, to the x power, and press graph. Yep. See, just check. Yep. Everything's good. 3 works also. We don't care about 2 because there's not a choice with all of them. So 1 and 3, definite. 3 is your answer. Number 20. Which system of equations has the same solution? Unfortunately, you do have to know how to solve these, right? So just remember, when we're talking about using elimination, we're talking about getting one of these, the x's or the y's, opposite of the other one, because you want it to cancel. So if this is a negative y and this is a positive 3y, we're going to just go ahead and multiply by a positive 3 to make this y a negative 3y. If it's a negative 3y, then we can cancel. And so I'm going to rewrite them just like that. And I'm going to have 11x. This cancels, and you have 33. Then I'm going to divide by 11. X equals 3. And that's that. So now I'm going to substitute in to get the y, and I'm going to choose this first one. So I'm going to go back over here. 3x minus y equals 7. All right, I'm going to put 3 times 3 in. I'm going to substitute that 3 in. I'm going to have this as the negative y of 7. This is 9 minus y equals 7. I'm going to subtract 9 on both sides. This negative y equals negative 2. And then I'm just going to put divide by negative 1 to get the negatives to cancel, because you can't have negative y, so y equals 2. So I'm going to just go to this one 4, and you see this x plus y equals 2. 3, my x is 3, my y is 2. That does not equal 2, that's out. Then I'm going to go to this one, 4 times 3 plus 6 times 2 equals 24. And let's see if that works out. That is 12 plus 12 equals 24. That works. Okay, so now I'm going to go to 18. I'm going to check the other one out, times 3 minus 6 times 2. So, and that works out. Let's see, 18 times 3 and 6 times 2. We just go ahead to the graph. 18 times 3 minus 6 times 2, just to make sure. And that is 42, and that is 42. This one is the answer. It's a little bit more work, but you got that one, right? Like, I mean, it is just solving for that system and then substituting it. So here's another one with the calculator. This is a function, population of paramecia, paramecia. P can be modeled using the exponential function p of t, p, and you're substituting that t in equals 3 times. All right, so we're going to put this into the calculator just like that, and now we have that in the calculator just exactly 3 times 2 to the t power, and we're going to press graph, and we're going to see exactly what that does, and that's what it does. All right, so now it's like, all right, so the domain, just take a look at the domain, and it says the first 2 weeks. So what is the t going to be? Oh, it's going to be first 2 weeks, 0 to 2. But what does t represent? T represents days. 7 days in a week, 14 days in 2. So that's why t has to be 0 to 14. Be careful with that. They're going to just like, maybe they'll do 3 days. T represents hours. And they say which domain can be most appropriate for 3 days. And you would have to do 24 times 3. All right. So just be careful like with that, like with the reading. This is kind of like a reading problem. And that's why it's tough sometimes. All right. Given the following data set, which representation is correct? So here's 65. Here's 1 dot for 65. There's 4 70s, 4 70s. 3 80s, 3 80s. 85, yep, 1. 90, 2 90s, yep. 3 95s, yep. 100. So this works. Then we're going to look at the frequency table. And we have 5, 61 to 71. We have 5. Yep, we do 1, 2, 3, 4, 5. And then we have 3, 71 to 81. And that's 1, 2, 3. Yep. And then we have 3, 81 to 91. 2, 3. Yes. And then we have 4 the rest of the way, 91 to 101. And so this is correct. Let me look at my choices. So 1 and 3 have to be in there. All right. 1 and 3 have to be in there. So 2 could be a possible answer. 1 and 3 have to be in there. Oh, all right. So now they're going to have me go and check to see if this works. This box and whisker plot. All right. So one easy way to do this is to actually put this into a list. All right. So we're going to do this as far as the list goes in the calculator, and then I'll show you how to do it by hand as well. So I have the numbers here because it's going to block out my screen. To get a list into your calculator, we are going to press stat. All right. If you've never done this before and you leave it on edit, you press enter. Right. And see this L1? We're going to put those numbers in 65, 70, 70 again. And we're putting the numbers in 70, enter. That's the third 70. We have 4 70s. We have an 80. We have 3 80s. Three 80s, and then we have an 85. We have 2 90s. We have 3 95s. And 1 100. We have 15 numbers in there. It's waiting for the 16th, and I'm going to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I inputted that correctly. So now the next thing that you do is press stat one more time. And then you go over to calc, and you leave it on 1 var stats. You press enter 3 times. And you will jump up to this screen right here. See this X with the line on top? That is the mean. That's the average. We are going to go down to the 5-number summary. And that 5-number summary is min, Q1, median, Q3, and max. Right? So we're going to just take a look to see if this box and whisker plot is good. So this is the minimum number. Min stands for minimum. Max is the largest number. And we could tell that by what they gave us. This, however, is Q1. This is the median, and sometimes known as Q2. And this is Q3. All right. So let's just take a look. The min is 65 and the max is 100. So we do have that there. And that there, 65 and 100. The Q1 is 70 and the median is 80. Q1 is 70, the median is 80, Q3 is 95. That all works out. This works too. And that's a rare question that all 3 of them work. Okay, so a recursively defined sequence is shown below. What's the value of a sub 4? All right, so a sub 1 is 5. So we're going to just put this into the calculator. 1, n is going to be 1 plus 1. 2 times a sub n. A sub n is the prior term. This is the 1. Remember, I substituted the 1 in. So 2 times 5. Minus 7. That's 10 minus 7. So a sub 2 is 3. Now, n is going to be 2 plus 1 equals 2 times a sub 2. That's 3 minus 7. So 6 minus 7, a sub 3 is negative 1. We need a sub 4. So it's 3 plus 1 equals 2 times a sub 3. A sub 3 was negative 1 minus 7. Negative 2 minus 7. A sub 4 equals is negative 9. Remember, this right here is always your prior term. So that's why you need the prior term to figure out the next term. It's a sequence. And that's it. 24. Which polynomial has a leading coefficient of 4 and a degree of 3? All right, so you have to put these in standard form if you really would like to. And just look at the highest exponent, the largest exponent, the greatest exponent, I should say. This is the greatest exponent. It does not have a leading coefficient. This number before the x is the leading coefficient. It does not have a leading coefficient of 4. The highest exponent is this right here. It's 3. So the leading coefficient is 5 and it's not 4. Here's the leading coefficient of 4. Here's the highest exponent and a degree of 3. That's a degree of 4. That's gone. Coefficient 4, degree of 3, 4 is your answer. So we're going to go into, that ends the multiple choice. We're going to go into the part 2. There's 8 questions in this part, and these are easier questions, kind of straightforward. Just remember, use your calculator, and that's what they want you to do right here. So what they want you to graph is f of x equals negative we're going to graph this. We're going to press y equals. We're going to put negative square root. Square root is right here. X. And then we're going to make sure that we're out of the radical, that square root symbol, and press to the right. And then put plus 1 down, and that is your graph. We go to second function, graph, and we see exactly what we have to graph. So I'm going to go to 0, 1. 0, 1 is right here, and that is my first point. Then I'm going to go to, let me put this down a little bit so I can see. 2, negative 4.14. I'm going to go to 0, 1. I'm going to go to 1, 0, which is this point. Then I'm going to go to 4, negative 1, which is here. And that's all I could fit. I might go to 3, negative 7.32, but you don't have to, because I like to have like where I'm going here, and that's around where I have to graph. So that graph is going to start like this right here, and then go along. And you see how like I need that guide? Need that guide. Like that. And I'm going to label it, even though you don't really need to label one when one function is on there. That is the graph. Number 26, Maria ordered t-shirts for a volleyball camp. I'm going to highlight here adult size t-shirts. Cost $6.25 each. Youth size t-shirts cost $4.50 each. Maria has $550 to purchase both size. If she purchases 45 youth size t-shirts, determine algebraically the maximum number of adult size t-shirts. They want you to set up an equation and then substitute the 45 in for the youth size, and then then solve for the other variable. And that's what they want you to do here. So, let's go ahead. Adult size t-shirts cost $6.25 each. So $6.25 plus $4.50 youth size. Someone put Y equals $5.50 to purchase. So I'm going to just go $6.25 plus the $4.50, and she bought 45 of them, so that's what I'm going to substitute in. So in order for me to do this, I need to clear this out and put in 450 times 45 to see how much that's going to come out to be. So I'm going to do 4.5 times 45. And I'm going to get 202.50. So I'm going to rewrite this over again. 202.50, whatever. 550. And then you minus 202, just like any two-step equation. Minus 202.50. And then we have 550 minus 202.50. And you get 347.50. with 625, and this 6.25a equals, then you divide, you're solving for the amount of adult t-shirts that you could buy. And when you divide that, you're dividing it by 625. And 55.6. So A equals 55.6 adult size t-shirts. But determine algebraically the maximum number of adult size t-shirts you can buy. A lot of people say 56 at this point, but it's not. It is 55. Maximum number. And that's it. 55, right? You can't buy 56 because you don't have enough money. 55.6, impossible to buy that in t-shirts. A news report suggested that an adult could drink 4 pints, should drink a minimum of 4 pints of water per day. Based on this report, determine the minimum amount of water an adult should drink in fluid ounces per week. So in order to do this problem, you have to go to this high school math reference sheet. And remember, it says 4 pints of water per day. So I'm looking at this right here, and I'm going to rewrite that 1 pint equals 2 cups. And then I'm going to have to go down to 1 cup equals 8 fluid ounces to make those conversions. So these two conversions on the reference sheet is what you need. So I'm going to go back to the other page and really write those down. So this is what I did. I did put down exactly what I got from the reference sheet. 4 pints of water each day. 1 pint equals 2 cups. 1 cup equals 8 fluid ounces. And it's asking how many fluid ounces should an adult consume of water per week. So per day, you take the 4 pints of water and you times it by 2 to convert it into cups. So you have 8 cups. You're supposed to have 8 cups as an adult of water every day. So there's 7 days in a week. So you do 8 times 7. So that's 56 cups of water that you have to consume every week. So then you take the 56 and then convert it into fluid ounces, because each cup equals 8 fluid ounces. So then you do 56 times 8 and you get 448 fluid ounces per week. And that is your answer right here. Anytime if they give you one of these conversion problems, just look on the reference guide. It should be there. And that's it. All right. So express as a trinomial in standard form. So the first thing I see is 2 binomials. I am going to do distributive property, FOIL, if you know it as that. 3x squared, 3x times 7 is 21x. Negative 4 times x is negative 4x. And then negative 4 times positive 7 is negative 28. And then I'm just going to put down the negative 1/4 x squared. I'm combining like terms. I see the like terms right here and here. And that is 2.75 x squared. And I'm just going to go ahead and combine the like terms right here and here. 21x minus 4x is 17x. And then minus 28 is left. Express as a trinomial in standard form. That is the answer. Full credit. All right, so John was given this equation, and right here, some of the steps and their reasons have already been completed. Name a property. So this is the given right here. This is what the given is. They want to know what's happening here. So obviously, I know what is happening is probably the easiest property to remember. It is distributive property. You can't say, a lot of times I like to say distributive property over addition, distributive property over subtraction, but that's just too much to explain because it is happening over both. So you just put distributive property, you'll get full credit. Then right here, they combine like terms. All right, that's what's happening here to here. And then something happens to get from here to here, right? So let's see what happened. This is what they did. So what did they do? It looks like they used inverse operations, but that's not a property. So what did they do? So this is called the addition property. Of equality. So it's just adding 14a on both sides of the equation. If you were subtracting, it would be the subtraction property of equality. And that is full credit. You're finished with that question. Moving on to number 30. This state whether the product of square root of 3 and square root of 9 is rational and or irrational. So square root of 3 is irrational. Times the square root of 9. Square root of 9 is 3. That's a perfect square. Is rational. When you multiply an irrational times a rational, you get an irrational answer. And that's what you have to state. And that is your answer. You could also put these into the calculator, and if you put square root of 3 times the square root of 9 into your calculator, like so if you just do this, they know you have a calculator. So, and you get that number. You could say their product is a non-terminating, non-repeating decimal, which is irrational. And that would work also for full credit. All right, number 31, use the method of completing the square to determine the exact values for the equation. The completing the square. So for completing the square, I'm going to write down the trinomial, quadratic. All right, and you must subtract 6 to get the c over to the other side of that equation. So it's not supposed to be equal to 0. And so that's the way it would be. So completing the square says that you take b, say you take b, which is 8, this is b, and you divide it by 2. All right? So then you take that answer and square it. You're completing the square. So this becomes 16. And what you do for completing the square is that you put x squared minus 8x plus 16. You can't just add 16 to one side and not add it to the other. All right, you're completing the square. So then I'm just going to rewrite this, x squared minus 8x plus 16 equals 10. Let me move down a little bit here. So what happens when you complete the square, you set up a trinomial that is equal to two binomials, but it's a square root. So it'll always be, you're looking for two numbers that multiply to 16, and obviously it's 4 and 4, And it'll be exactly the same number. And it's negative times a negative because that'll be a positive. So this is x, minus 4 and minus 4. And that'll always be like that because you just completed the square. You divided b by 2 and then you squared it. All right, so then all of a sudden on the other side you have 10. So don't get confused here. This is negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. So it'll always work out that way when you're completing the square. So when you have the x minus 4 times like x minus 4, you could shorten it up to that. And remember, you do have to solve this. So we're going to square root both sides. The opposite inverse operation of square is square root. So this square root kind of cancels out the square, cancels out with the square root. I'm going to go over here and do x minus 4 now equals, and then remember, when you take the square root of a number, it is positive. There's a positive root and a negative root. Okay. So now I'm going to solve. I'm going to break it up into two equations, and I'm going to solve it. So I'm going to break this up into two equations. I'm going to have x minus 4 equals square root of 10. And then I'm also going to have x minus 4 equals the negative square root of 10. Because remember, we're solving for the solutions, right? So I'm going to add 4 to both sides. This is x equals 4 plus square root of 10. And then this is x equals 4 minus square root of 10. And those are your two roots. Let me just go back up and say, it says, I just want to make sure you understand when it says exact values of x, you must not round. So these are the exact values of x. Exact values of x. Square root of 10 is non-perfect square. So if you took the square root of 10 and put it into your calculator, you would not get an exact number ever because it's a non-terminating, non-repeating decimal. So x equals 4 plus the square root of 10 is the exact number that it crosses the x-axis. And then x equals 4 minus the square root of 10 is the exact number it crosses the x-axis. All right, and those are the answers. All right, the formula for determining the finite sum of s, arithmetic sequence of numbers is s. Oh, that's nice. S equals n over 2 times a plus b. All right, so where n is the number of terms, a is the first term, b is the last term, who cares? Express b in terms. So they want you to solve for b. Please do not distribute. Do not distribute. I know that all math teachers tell you to distribute, but not when you're solving an equation that is a literal equation. That means it has all variables, like more than one variable, right, all over the place. You're solving this for b, which is this. So we're not going to distribute. So I always ask my students all the time, if you had one term to kind of cancel out and you wish it was gone, what would that term be in this equation? Well, the n over 2, if that fraction was gone, b would be really easy to solve for. So just remember, every time you want to get rid of a fraction, you multiply by its reciprocal. But I'm going to do one step at a time. I'm going to just do it one step at a time. So I'm going to multiply by 2. I'm going to multiply by 2. And what happens is that this 2 cancels with this 2. All right. And what you have is 2s equals n times a plus b, and that's it. The 2's are canceled. So then, how do I get rid of this n? Well, it's just like if you have 5x equals 20, you would divide by 5. Well, it's the same thing. You want to get rid of the n. This is attached by multiplication. You're dividing. So this cancels, this cancels. Then you have 2s over n equals a plus b. Did you get rid of the fraction? Yes, you did. Did you want to get rid of the fraction? I hope so. So you have to solve for a, right? No, solve for b. Express b. So you minus a on both sides. This cancels. So you have 2s over n minus a equals b. And that is your final answer. Solve for b. Right? Don't distribute. You just make it more difficult. Get rid of the fraction first. They always give you something like that with a fraction. All right, this is part 3, number 33. Michael threw a ball in the air from the top of the building. The height of the ball is modeled by this equation where the t is elapsed time. Graph this equation and determine the average rate of time. All right, so I'm going to rewrite this h equals negative 16t squared plus 64t plus 60. Right? I'm obviously going to put that into the calculator, and I'm going to just mess with this view just a little bit here because it has to be smaller. And then I'm going to grab the calculator and put that in. It's my y1. So that is negative 16t. And that's x squared plus 64t. X plus 60. So the problem is, though, I have that. And I'm just going to look at this and just see what they gave me. They gave me a y that increases by 10, by tens. And they gave me x's that increase by halves. So first thing I want to do is actually mess with the window a little bit, because the y max, I need to see the top part of this parabola. So I'm going to put that at 300. I'm just going to pick a number and just hopefully I'm going to lower it down a little bit to 200 just so I could see more of it. Okay, that's pretty good. So I'm looking right here. This is what I have to graph. And because they gave me just the positives, right? So I'm going to go back and I'm going to mess with the table set. So I'm going to put this, since they have, and you don't have to do this, but I'm just doing this because the table, the graph that they gave me is increasing the x's by halves. I'm changing it to a half so I could see what each half is. So I'm going right here. I'm starting at 0, 60. So I'm going to go down to 0, 60. So 0, 60 is right here. And then you see this half, 88. Half 88 would probably be around there. You don't have to even graph it if you don't want to. 1, 108. 1, 108, which is right here. $1.5, 120. 1.5, 120. 2, 124. 2, 124 would be right about there. 3, 108, 2.5, 120. Where am I? 2.5, 120. And notice that the parabola is starting to come down now to decrease. 3,108. 3.588. And that's 460. Just going to check that out. 4.524. Right about there. And I want to see what it is at 5. It's negative 20. So I think that's about it for me. So now I'm going to just go ahead and draw my, oh boy, that's bad. Let me just get that out of there. And it's bad again. All right. All right, that's pretty bad. But I don't care. Right about there. All right, so that is my parabola, and that's it. So it says determine the average rate of change in feet per second from when Michael released the ball. So this is that right there. So that's 0.60 to from when it reached the maximum height. So it reaches the maximum height here at 2. So I just want to make sure to 124. So to get the average rate of change, you have to go back to y2 minus y1 over x2 minus x1, and then put that in to the calculator. 124 minus 60 divided by 2 minus 0, and you will get 32 feet per second. M equals 32 feet. And that is your answer. All right. So it says graph the system of inequalities on this graph. And Stephen says that the point of is 0, 0 is a solution to the system. We'll worry about that after. So we are like, I took that first inequality and just went ahead and solved it for y. Remember, you can't graph anything that is not solved for y. Once you put that directly into the calculator, remember you have to put this, which is the less than symbol, in. And the best way to do that is to go to the leftmost portion until that's blinking. You press enter and you go down, and then you go to the right. That is greater than. Go to the right one more time. That's less than. Then you will go to OK, and you could go ahead and graph that line. See, now this right here is where I messed with the window. So you press zoom and standard, and you'll get back to the original window, 10 by 10, and that is what I have to graph. So I'm doing this by hand. All right, I'm not looking at my calculator because I know in 8th grade, and by the way, this is a less than symbol, so you're going to put a dashed dotted line because, again, it's not equal to, it's less than, so that means less than is shaded below, and if you look at your calculator, you'll see it's shaded below. The y-intercept is 2, and the slope is 1 over 2. So I find it easy to just do it by hand, but you could you put it into the calculator like I did show you, and you look at the table, and you'll see exactly what coordinates to graph. So this is y is less than 1/2 x plus 2. And so now we're going to take that second equation, and we're going to put this 3x plus 4y plus 4 is greater than or equal to 0. Remember, you minus the 3x on both sides, minus the 3x on both sides, and then minus the 4 on both sides also, because you have to solve for y. So then you have 4y is greater than or equal to negative 3x minus 4. This is not an easy question at all. All right, you're dividing by 4 on both sides. This is y is less than or is greater than or equal to negative 3 over 4x minus 1. And when you put that into the calculator, just remember this is a greater than symbol. So you go all the way over to the, I'm pressing down to the left, and it's greater than, so I'm going to press enter, and I'm going to go down to line, and I'm going to press to the right, and that is the greater than symbol. So I'm going to go to OK, and now when I graph it, I can see exactly what I have to graph. So you will always go to second graph to see exactly what you would graph. And by the way, I messed with the window. I messed with the table set. So I'm going to go back to that being 1 so I could see exactly what I have to graph. Always skip the fractions. But again, on this, for this slope, it's a negative 3 over 4 slope. So that means it's going down from left to right. So just going by hand and then going back to doing it by hand, it's a negative 3 over 4. So it's down 3 and to the right 4. The b is negative 1. So it would probably take me less time to do this by hand. If I start at negative 1, right? And I have to go down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Down 3, 1, 2, 3, 1, 2, 3, 4. And that's all I could go. I can't fit any more. Then on the other side, I have to have some more points. So I go up 3, 1, 2, 3, and to the right, to the left 4, 1, 2, 3, 4. And that will keep see how like the points are in line. 1, 2, 3. 1, 2, 3, 4, and that's about it for that. This is a greater than or equal to, so that means the line will be solid. So there's my line. Just making sure I put arrows on either end. On each end. And I have to shade. This is greater than. So I'm shading up. Up just like that. And once I shade up and once I get to a certain point, you see the point that that the double shaded area exists. And right there is your double shaded area. I'm going to put a giant S in that double shaded area to mark the solution. And the second question, it says, Stephen says that the point 0, 0 is a solution and determine if he's correct. So I'm going to put 0, 0 on the graph, and the 0, 0 is a part of the solution. It is in the double shaded area. And that's all you have to say about that. All right, so next problem is number 35. It says the following table represents a sample of sale prices in thousands of dollars and new homes available at that price. So state the linear regression function that estimates the number of new homes available in a specific sale price and round all values to the nearest hundredth. So to do this question, you do have to, and I'm going to be pausing here a lot because I'm not going to let you sit here and just watch me input into the stat, into the list of the calculator. Well, you do press stat and press enter. And then once you get to this list, that was the question that we did before. So if you're following along and you have numbers in there, you just go up to L1. Please don't press delete. Do not press delete. Press clear. And you'll see all the numbers from the bottom go away. And then you press enter and you'll see exactly that your list is now clear. So what you have to do is that you're going to put the top part of your the data in as L1 and then the bottom part as L2. All right, so I'm going to put that into my calculator. You do the same, and when we come back, I'll have that all in. Oh, just be careful. It's in thousands of dollars, by the way. So this is $160,000. This is $180,000. You don't have to put that directly in unless you really want to. But I'm just telling you that thousands of dollars, not just 160. So I put it in, I did decide to convert it to thousands of dollars because if you do forget later that they're thousands, then you're going to come up with the wrong answer. So the first question says state the linear regression function that estimates the number of new homes available, and then the correlation coefficient is next. So just make sure that you when you press mode, that this is very important because they usually ask you to reset the calculator. So once they ask you to reset the calculator, the stat diagnostics is off automatically, and you won't see the linear regression. You won't see the correlation coefficient. So just press mode and then you go down all the way to stat diagnostics. And if it's off, you must turn it to on, all right, by pressing enter. And you can press down and to see that that is shaded in. So just remember that. So here's my list, all right. And now I'm going to press stat one more time and I'm going to go to calc and I'm going to go to 4, linear regression, AX plus B. And I'm going to press enter 1, 2, 3, 4, 5 times. And there is all the information that I need for this question. All right. So this right here, this A, is what you're going to use as your slope. And this B is what it is as your y-intercept. And R is the linear regression. All right, I'm sorry, the correlation coefficient. So I'm just going to put those numbers down as the linear regression equation. So this is F P is negative 0.79. X, round to the nearest hundredth, plus 249.86, round all values to the nearest hundredth, and that now the correlation coefficient, just remember the correlation coefficient is negative 0.95. Correlation coefficient R equals negative 0.95. and explain what it means in the context of the problem. The correlation coefficient suggests a very high negative correlation between, use the words that they give you, sales price in thousands of dollars and number of new homes available. All right, and I'll come back and I'll write that. And that is your answer. Correlation coefficient suggests a very high negative correlation between sales price and the number of new homes available. All right, the length of a rectangular sign is 6 inches more than half its width. The area of the sign is 432 square inches. Write the equation of one variable in one variable that can be used to find the number of inches in the dimensions of the sign. So the first thing that I did here is to just put the length down and the width. And the width is my W. The length is 6 inches more than half the width. So a half W, 6 inches more. So that means it's plus 6. So that is what we're looking at. Now, solve this equation. All right, it says write an equation first off and then solve the equation. So the equation would be area equals it's length times width. So area equals, and this is basically what I would put down, W times 1/2 W plus 6. And then now they gave you the area, so I'm going to erase this. This is 432. 432, the area. So I'm going to just rewrite that and I'm going to put the W 1/2 W plus 6 first equals 432. So in order to solve this, I'm going to do distributive property. This is W 1/2 W squared plus 6W equals 432. To make it easier for myself, and this is just because I don't like the half, I'm just going to multiply this whole thing by 2. So what's going to happen is that the 2 and this 2 cancels out. So with that 2, so I'm going to get W squared plus 12W equals 864. And then I'm just going to I'm going to try to factor this, right? So I'm going to complete the square. So the completed square, remember, B divided by 2. So 12 divided by 2 is 6. And then 6 squared is 36. So when I rewrite this, this is W squared plus 12W plus 36 equals 864 plus 36. So what I did was, well, let me just rewrite this. Equals 900. So what I did was that I made that trinomial, when I factor it, it's going to be the product of two binomials that is a perfect square. So 6 times 6 is that 36. All right, it still equals 900. When I rewrite it, it's going to be W plus 6 squared, because it's the same thing twice, equals 900. So the opposite of squared is square root. So I'm going to square root both sides. This cancels with this. And this is W plus 6 equals. And what is 900 times 900? This is, 30 times 30 is 900. So, and that is a perfect square, so that's why that works out nicely. All right. So when you go ahead and you split that into 2, like I did before, that's W equals 30, W plus 6 equals 30, W plus 6 equals negative 30. So when you subtract 6 on both sides, you get a W of 24. I'm not going to focus on this side because if you minus 6 on both sides, W equals negative 36, and there's no negative lengths and widths. All right. So you have a width of 24, and the length I put all the way up here as a half W plus 6. So the length, that's nice, is a half W plus 6. So length is half of 24 plus 6. Length equals 12 plus 6. Length equals 18. Width is 24, length is 18, and you're finished. All right, last question, part 4, is a 6-point question. 2 families went to Roller Coaster World. Brown family paid $170 for 3 children and 2 adults. So the child ticket is Y, and the adult ticket, Y is the adult ticket, child ticket is X. All right, so X and Y. So 3 children is 3X, 2 adults, 2Y. 4X, 6 adults, 6Y. So you have 3X plus 2Y equals 170. And then you have the Peckham family for 4X plus 6Y equals 360. You have to graph each one of these on the graph given, and then answer questions based on state the coordinates of the point of intersection, explain what each coordinate means. It's in the context of the problem. This is a long problem because it is a very, it's a 6-point question. That's the reason. So what I did was minus 3x on both sides, then divided by 2 to get the y alone, and it's negative 3 over 2x plus 85, so 170 divided by 2. On this one, you just minus the 4x on both sides. You get 6y equals negative 4x plus 360 divided by 6, and you get negative 2 over 3x plus 60. And now we have to graph both of those, and so we're going to put those into the calculator and just go separately, which, you know, one at a time, just to make sure that I don't mess up. So you could see I have my first equation in there, and then when I go to press graph, I don't see anything on the graph. Well, then I look at what the Regents gave me. The Regents gives you a graph that goes by 10s, actually goes by 5s. So what I'm going to do is that I'm going to extend this graph all the way up. I'm going to use the window. And I don't need to see anything of the negatives. Negatives are gone. And then I'm going to extend the graph all the way to 90 for the x max, because that's what the graph on the Regents gives. And then the y max would be also up to 90 because that's what they give you. So then when I press graph, I'll be able to see, all right, that's what I'm supposed to graph. And then I could press second graph. And instead of leaving this going by 1s and cycling through it, I'm going to table set and then go by 5s. All right, so now press second function graph, and you'll see exactly what it is that you have to graph. So 0.85 is the first point. And I'm going to skip all of the fractions. So 1070 is the second. So I could see I'm going down 3 and to the right 2, down 3 to the right 2. I'm not going to cycle back 1, 2, 3, 1, 2. So this is linear, 1, 2, 3, 1, 2. That's how I'm sure that I'm going to get the right answers here. So at 60, I just want to make sure what 60 is. 60 is -5. So we're at 60 right here. So I'm just going to put it right directly above, like before that. And I'm going to just connect the points that way. So almost at 60, but not quite. Something like that. All right. So that is y equals -3 over 2x plus 85. And then we have this one. So I'm going to go back to my calculator. Y equals -2 over 3x. Alpha x, -2 over 3x. I'm just going to check to see plus 60. And I'm going to graph. And you can see right now that my table, everything is already set. So I'm going to just make sure I go to 0. And I went right past there. So 0, 60, that's where it starts. And I'm going to go down 2 and to the right 3. And really, that's not down 2. It's, you know, I mean, it's down 10. Let me just check to see if that's correct because I'm not sure here. So this is 10, 15, 50. Yes. 15, 50. So down 2 and to the right 3. Down 2 to the right 3. 1, 2, 3. Down 2 to the right 3. Down 2 to the right 3. And down 2 to the right 3. It ends right there. I'm going to draw my line. And I'm going to just make sure it's just a little bit further up. And there is my solution. State the coordinates of the points of intersection. It is 30, 40. Explain what each coordinate means in the context of the problem. So in the context of the problem, the price of an adult ticket is $40 and the price of a child ticket is $30, and that's what it is. That ends the Regents. That is the last question. And remember, anytime that you need a formula or anything like it, look at the high school reference sheet in the back. It has a lot of good stuff on it, quadratic formula, and, you know, any kind of conversion that you need to use. Remember, if you forget your calculator, that's going to be a problem. We used the calculator a whole bunch of times during this exam. Just use it as much as you possibly can to even check your answers for the open-ended. And that's it. Thank you for watching, and I hope this helped. Bye, everybody.